Hi everyone. Reading Semantics on relevance aggregation for neural networks, interpretability, and knowledge discovery on tabular data. And initially, I did on the summary of the paper. In summary of the paper, these are the references of the paper which I did. These three are the references of the paper. And coming to the purpose, in purpose. In spite of their potential usefulness, neural networks has been slow to catch on due to their perceived difficulty. The adoption of tabular data has been gradual despite widespread enthusiasm for researchers and businesses. This is because mostly works only explain the projections without really examining them. This study explains how Reliance aggregation works in detail, assigning weights to features in input data and generating scores for those characteristics using the neural networks. Acquired expertise is what this technique is all about. Additionally, we provide two distinct ways of visualizing the lawn patterns, each of which contributes to a better comprehension of the model. Effectiveness on classification and regression tasks was evaluated using both synthetic and real-world databases, such as breast cancer, gene expression, internet pursuing behavior, and results from the National High School exam. Success in isolating the network's nerve centers has been linked to more accurate forecast. Each group may choose from themselves mm, whatever set of traits they find most useful. The rankings of future scores is based on the relative contribution of each further to overall model accuracy. The results guided the choice of informative data qualities, which allowed from more data collecting. Features that improve the effectiveness of another classifier tended to perform well. A neural network that has not been properly trained may not be able to detect biased or incorrectly implemented rules. That's why we need aggregate relevant information. And the related literature is the use of interpretable algorithms, however, allows us to look at a trained model and figure out what features it picked up while being subjected to mm, no selection at all. Once it has been determined which attributes are superfluous or incompatible, the model may be retained using the just the better subject of input characteristics, leaving out the rest. Finding specialists in specific disciplines where human intuition or domain knowledge is lacking is one of use systems. More specific applications will be examined in section 4, and by presenting potential adjustments to exciting approaches, this reaches tackles the problem of interpretability in neural networks trained on tabular data. As a result, we may be able to address the issue of interpretability in neural networks that are educated using the tabular data. In addition, many visualization and validation approaches are used in combination with a synthetic and a real-world databases to confirm the interpretation result. And in a research design or a strategy, these models were similar but disgraded anyhow. To open black boxes in the neural networks without compromising their advantages, such their ability to handle nonlinear issues and learn features autonomously still present challenges that need to be solved. After this section, you will have a better understanding of one method for accomplishing this rule. Now, the explainable ML has arrived. We have a whole new tool for selecting features to include in our models. ML machine learning models generalization, prediction, performance, and stability may be enhanced by using feature selection technique on high dimensional data sets that include irrelevant, redundant, or noisy input features. Typically, a selection is made before any form of processing takes place. And in results discussions and conclusion, some examples of the types of information included include cancer, patient microarray, gen expression data, forensic single nucleotide polymorphism data, medication data, and COVID-19 patient hemogram test data, online shopping data, and astronomy data. While artificial neural networks has shown some promise in producing accurate forecasters, their results may be difficult to comprehend. Therefore, they are not yet extensively used for analyzing this data. For instance, Lamy and against using deep learning on tabular based cancer data, and they make the observations that doctors and other healthcare workers do not place as much value on deep learning as they do on their forms of education. Because of this mystery, simplistic linear and statistical models were developed without taking into consideration the inherent complexity and nonlinearity. And coming to the contributions, a nice illustration of this large concept may found in the case study. In this piece, we will talk about a strategy that makes advantage of the fact that tabular data provides a stable representation of dimensions. Tabular data and visualized data may need different vocabularies. When feeding data in a machine learning model, pixels may be referred to as inputs or dimensions, while features are often reversed for higher orders information, and the structures like edge detectors. Working with the tabular data may sometimes make the distinction between the two terms unclear. Columns in a table may be called dimensions, inputs, or features depending on the context. While tabular data is far more common in disciplines of a science, um, in on industry data in the forms of images text is so special to research and deep learning. This is so despite that fact that much information available in these fields is in tabular form. And after that, coming to critical analysis. In critical analysis, the overall assessment, the meaning of the data provided by the samples will not change if the vector of dimensions here represented by the table columns is permuted as a whole in the same manner. This quality is most not noticeable when constructing is image data, where the dimensions has a spatial structure. When information is tabulated, it is not organized geographically. The sequence in which a image's pixel are shown may drastically affect its meaning. The significance of a given pixel in one sample may not be the same as its significance in another sample, even though the two samples have the same relative position. Since the same dimensions will always have the same meaning regardless of the sample. This issue does not arise when examining tabular data. And the research methodology failure to explain the reasoning behind decisions may lead to poor productivity, distrust, and even animosity towards the robots. Neural networks and the other predictor, such as support vector machines, may help machine learning systems and generate predictions, but it can be challenging for humans to understand the reasoning behind the systems. Studies of neural networks, circuits, and other work on the interpretability of neural networks have recently focused on visual data while developing cutting edge methods like deconvolution and visual back prompt. We kept convolutional neural networks in mind while dealing with the tabular data. Surrogate model algorithms like local interpretable and model and exotic explanations have trouble due to fuzziness of the concept of neighborhood. And the further research of the paper is paying attention also serves as a source of creative inspiration for writers, methods that may be used within neural networks varieties that do better when fed tabular data or the primary focus of the investigation, since they better explain individual predictions. Some particularly effective methods are sensitivity analysis and deep lift. Algorithms like this will be studied more thoroughly in the future. Tabular data refers to data that is not organized yet, is shown in tabular format. Different types of data, binary, continuous, ordinal, and categorical, may be represented in this format. Samples as rows and dimensions as columns. Samples as rows and dimensions as columns by unstructured, which means there is no clear geographical or temporal relationship between the data's may features. This is what we mean when we talk about data being unstructured. And new knowledge learned from this paper is, despite being complexity acceptable, neural networks are sometimes referred to as a black box. Despite their rising popularity and the state of the art performance across a wide variety of challenging tasks. Even with the dramatic emergence of neural networks, this remains true. They are notoriously difficult to characterize and forecast in terms of their learning behavior due to intrinsic intricacy of their structures, which only serves to heighten the challenge. In certain circumstances, the learned properties of the input to output transformation may have latent traits that can only be expressed via a high number of hidden model parameters. And finally, we have questions to discuss. In this paper, I need to discuss two questions. One of the question is, what other hidden parameters are there? I need to know what are the parameters are hidden. Other parameters are hidden. And the second question of this paper is, what model uh, agonistic explanation? I need to know the model explanation of this one. These are the questions I have the question. These are the two questions I raised, and that's it. And the thank you.